Good afternoon, everybody. My name is Henry Brown, and on behalf of the Global Support Services Leadership Team, I'd like to welcome you to VMworld 2011, to the Global Support Services Customer Support Day breakout session on best practices for virtual networking. Just a quick show of hands. How many of you have been to our support days before? Not many? Well, welcome all of you. At this time, I'd like to introduce David Garcia. He's one of our senior network technical support engineers at VMware, and he's going to be presenting this session to you. Thank you.
Thank you, David. Thanks. Thank you, Henry. Hi, everybody. How are you doing today? Thanks for coming out. And so I'll be presenting here. And on our agenda here, we have a virtual network overview. And we're going to be looking at vSwitch configurations, tips and tricks, troubleshooting virtual networks, what's new in vSphere 5.0, and network design considerations. So we'll get started here. And beginning with the virtual network overview, we're going to take a look first at the physical to virtual side. So on the physical side, we're looking at conventional access, distribution, core design, and a design with redundancy for enhanced availability. And on our virtual side, under the covers, virtual networking is the same as physical. The access layer is implemented as virtual switches. We have several different types of virtual switches in vSphere, and we'll go over those here. So we have the vNetwork standard switch. The model is host-based, one or more per ESX host, and it's the same as the vSwitch in VI3. And then we have the vNetwork distributed switch. Distributed model, one or more per data center, and it's an expanded feature set. So we have private VLANs, bidirectional traffic shaping, network vMotion, and simplified management. And then we have the Cisco Nexus 1000V. So that's a distributed model, one or more per data center, and it features a Cisco Catalyst Nexus feature set, the Cisco iOS command line interface, and it supports LACP. And just keep in mind that virtual networking concepts are similar with all of our virtual switches. Now for the virtual switch, just right out the door here, capabilities. We do NIC teaming of the physical NICs, the uplinks associated with the vSwitches. And it's a layer 2 model, so we only forward frames from VM to VM and VM to uplink. But we don't actually forward between the vSwitch and vSwitch or uplink to uplink. And the vSwitch will not create loops affecting spanning tree in the physical network. We can terminate VLAN trunks with our virtual switch tagging mode or pass-through trunk through the VM virtual guest tagging mode. And for our distributed virtual switch here, we have a comparison. So on one side, we have the standard vSwitch. And in this model here, you can see the vCenter and the ESX host with the vSwitches below them. And on the other side, we have the vNetwork and the distributed virtual switch. And you can see that that is presented as one switch across the host. And what we're looking at here, it exists across 2 or more clustered hosts. It provides similar functionality to vSwitches, and they reside on top of hidden vSwitches. vCenter owns the configuration of the DV switch, and we have consistent host network configurations. And then we have our port groups. They're templates for one or more ports with a common configuration. So here is where we set up the VLAN assignment. We do security. So you can set up the promiscuous mode, MAC address changes, forwards transmits. We can also do traffic shaping, so limit the egress traffic from the VM, and failover and load balancing. And then on the distributed virtual port group for our distributed virtual switch, we actually support bidirectional traffic shaping, ingress and egress. And then we preserve the state of the port during the vMotion. So with the network vMotion, we'll keep that port state preserved across the migration. And for NIC teaming and availability and load sharing, Our NIC teaming, we aggregate multiple physical uplinks for availability to reduce the exposure to single points of failure. So we're looking at the NIC uplink or the physical switch. And load sharing, we distribute the load over multiple uplinks according to the selected NIC teaming algorithm. And our requirements for this are 2 or more NICs on the same vSwitch. And our team NICs must have the same VLAN configurations, or what we basically recommend is they should be in the same layer 2 broadcast domain. And with our NIC teaming options that are available for us to use, we have originating virtual port ID. That algorithm is chosen based off of the vNIC port, so as you plug in the virtual machine on the vSwitch, it's just the next available port. And the physical network considerations for this is to have the team ports in the same layer 2 domain. And our best practice for this is to team over 2 physical switches. The next type that we have available is the source MAC address. And that's the MAC seen on the vNIC. Keep that in mind that it's not the same as the load balancing algorithm on some of the Cisco switches, typically associated with Ether channel. So this is just based off of the MAC seen on the vNIC. I see a lot of folks making some confusion or mistakes around this, so just watch out for that. And the physical network considerations, once again, is team the ports in the same layer 2 domain, basically the same VLAN configuration, and best practice is to team over 2 physical switches. And then we have IP hash. That algorithm is based off of a hash of a pair of source IP and destination IP. And the team ports are configured in a static 802.380 Ether channel. We don't support LACP unless you're using the Nexus 1000V. And you need multi-chassis Ether channel to span 2 switches. So if you're familiar with the virtual switch stacking, and that's basically what you're needing to do. So you can't do that across disparate trunk switches. And finally, we have explicit failover order. So it's our highest order uplink from the active list. And our physical network considerations for this is team the ports in the same layer 2 domain. And our best practice is to team over 2 physical switches. Our best practice is basically for by default, is just to use the originating virtual port ID. You don't have to do any special switch configurations. Just by default, you set it up, and there's no extra config required. The only thing is that the physical switches must be in the same layer 2 broadcast domain. So just keep that in mind, and it pretty much makes it pretty easy to configure. For IP hash, we have to ensure that the physical switch is properly configured for Ether channel. I see a lot of customers making some mistakes when they go down that route, and we're going to cover in a little bit more detail what exactly you have to do to configure Ether channel properly. Oh, and by the way, I have some KBs here, so if you download the presentations, there's sample configs and a little bit more information than I can give in the session, so you can come back to those. Then we have the Cisco Nexus 1000V. So this particular switch is a software switch for the vNetwork distributed switch that has 2 components. We have the virtual supervisor module, which is for the control plane, and then we have the virtual Ethernet module, which is for the data plane. And things to remember with that is the virtual Ethernet module, the VSM specifically, uses the external network fabric to communicate with the VIMs. And the VSM does not take part in forwarding the packets, is the control layer. So the VIM does not switch traffic to another VIM without an uplink, so it requires the physical infrastructure in order to switch that traffic. And here we have our VIMs. They're going to reside on each of the ESX hosts. And then you can see that makes up the Nexus 1000 virtual distributed switch. It's seen as one switch, across all of our ESX hosts. Keep in mind, this is the first third-party switch that actually implements the vNetwork distributed switch API. And the virtual supervisor module, like we said, it takes the control plane. It basically runs as a virtual or physical appliance running the Cisco OS, and it supports HA, so you can have active and standby configuration or failover. It performs the management and monitoring and configuration, and it's tightly integrated with the VMware Virtual Center. And then we have the virtual Ethernet modules, so these reside on each of the ESX hosts. And that enables the advanced networking capability on the hypervisor itself. And it provides each VM with the dedicated switch port. So just remember, the collection of VMs is one distributed virtual switch. And the Nexus, basically what it enables, it gives us the ability to have policy-based VM connectivity and mobility of the network and security properties, and really a non-disruptive operational model. So we're going to talk about vSwitch configurations next. And before we talk about the virtual configurations, as a starting point, I want to start off on the physical side. So just a show of hands, how many here are actually network admins? Okay, we got quite a few. And the rest are most likely, I hope, VM admins. Okay. So what we want to do before you embark on configuring networking is to get the configuration of your environment. And one of the things that I recommend for most customers is to get that configuration of your switches, if it's Cisco or whoever you happen to be using. Cisco, it's easy enough to run the commands in privileged exec mode, and it's a show run or show tech support. And keep a copy handy there, or request one from the network admin. And you can use that to compare to the sample configurations, specifically when you're taking a look at 802.1q VLAN tagging, and also the 802.3 AD link aggregation, or Ether channel. And so we have our starting point with our configuration that we obtained from the network admin. And we want to kind of take a look at what traffic types do we have on the virtual network. And we'll start off with virtual machine traffic. So that's the traffic sourced and received from virtual machines, and we'll probably have to isolate those based off of a particular service level. And then we have vMotion traffic. So that's the traffic sent when moving, a virtual machine from one ESX host to another. And that should be isolated. It's a required 1 gigabit connection and isolated from the other traffic types. And then our management traffic. That should be isolated from the VM traffic. And we're talking about 1 or 2 service consoles or VM kernel interfaces if you're using ESXi. And if we're using VMware HA, we're also talking about heartbeats as well. And then we have IP storage traffic types. So NFS and iSCSI via the VM kernel interfaces, those should be definitely isolated from the other traffic types. And then finally, we have fault tolerance logging traffic. So we're looking for low latency and high bandwidth. And that should definitely be isolated from the other traffic types. And what that brings us to here is answering this question is, how do we maintain traffic isolation without proliferating NICs? And we're looking at VLANs, or 802.1q VLAN tagging. So let's kind of dive into that and see what we're talking about here. So we have our port groups here and dedicated VLANs on a management-only virtual switch. So you can see here on one side I have the service console and the VMK interface. They're VLAN tagged for the services of vMotion on VLAN 106, storage is on VLAN 107, and management is on VLAN 108. And then our virtual machines are actually residing on another virtual switch. They could be in their own layer 2 broadcast domain or further isolated from each other. And you'll notice as well, too, on the physical layer, we actually have them isolated onto and dedicated to specific physical NICs. And we have 3 different types of VLAN tagging options that are available for you to use. The first one is external switch tagging. So with this particular configuration, there's not much that you actually do on the VMware side. You just set a VLAN tag of 0 on the port group. And the core of the work is actually done on the physical switch. So you configure the physical switch with the switch port access VLAN, and you actually set the VLAN tag for the broadcast domain there. And then the next type we have available is a virtual guest tagging. The tagging there is actually done within the virtual machine guest operating system. So we apply the VLAN tags there. And it's specific, for the Windows driver versus the Linux driver to configure that and set that up. I don't normally see that as a common configuration in virtual environments, but it's available for you to use if you need to. You set the port group VLAN to 4095 to accommodate that, to pass all of the VLAN traffic. And then for the physical switch, we do require that the physical switch is configured as a switch port trunk, and we have the allowed VLAN range. So that'll be anywhere, from between 1 and 4094. You just have to ensure that you're passing the right VLANs on the physical side, so that way the guest tag can be applied on the virtual side. And then we have virtual switch tagging. This is the most common one that we see out there in best practice. So the VLAN is assigned in the port group policy of the port group, and the VLAN tags are actually applied within the vSwitch. And then on the physical switch, what we're looking for is to have switch port trunk again set up with the allowed VLAN range anywhere from 1 to 4094. And I have an example here that kind of goes into a little bit more detail on that. So we're looking at 802.1q VLAN tagging, and we have uplinks A, B, and C connected to these trunk ports on the physical switch, which are carrying the 4 VLANs of 10, 20, 50, and 90. You probably can't see the interface configuration there, but we're set up as a switch port trunk encapsulation .1q with a native VLAN of 999, and then switch port trunk allowed VLAN, 10, 20, 50, and 90. And switch port mode trunk is the config on there. And there's another option in there, is spanning tree port fast trunk. We'll kind of get into that in a little bit. So ports 1 through 14 emit untagged frames, and only the frames tag with their respective VLAN ID. So kind of think of that as being equivalent to the access port on the physical switch. And the port group VLAN ID is set to anything between 1 and 4094 within that range. And then we have port 15 here. So that emits tag frames for all the VLANs. And that port group VLAN ID is set to 4095 for the vNetwork standard switch, or VLAN trunking on the distributed virtual switch DV port group. That is a special VLAN ID for virtual guest tagging or packet capturing and monitoring as well. And then we further extend that with our DVS support for private VLANs. So with a private VLAN, what we're looking at, we can enable users to restrict communications between the VMs on the same VLAN or network segment. And we have 3 distinct types of private VLANs. So we'll start off with the community type. So the VMs there can communicate with VMs on the community private VLAN type, and we also have the promiscuous private VLAN type. The next one is the isolated private VLAN. So those VMs can only communicate with VMs on their promiscuous private VLAN type. And then finally, we have the promiscuous private VLAN type. That one, basically, all the VMs there can communicate with all the VMs on the community and isolated private VLAN types. And what that allows us to do is to have the devices share the same IP subnet while being layer 2 isolated. And the benefits of that is we can employ larger subnets, and it's advantageous to hosting environments or multi-tenant environments. And we can reduce the management overhead. So we have a representation here of this. So in our DMZ network, we have our web server and our application server and database server on the community private VLAN. And then those VMs can communicate with each other, and also that router in the promiscuous private VLAN. And then you see here we have a requirement where the email server and the document server are in isolated private VLANs. They'll be on that same network segment, but they can't communicate with each other because that's our service requirements to keep them isolated. And they can communicate with the router in the promiscuous private VLAN, but you notice they can't even communicate with the community private VLAN directly. And we also can see a cost benefit from this. So let's say, for instance, on our normal requirements here for isolation, the VMs, we have 12 VMs, and they have to be on different network segments. So we're going to need 1 VLAN for each of those. So we'll end up with 12 VLANs across our distributed virtual switch here. Or what we could do is we could set up 1 private VLAN and realize 90% savings by doing that. So we're going to talk about link aggregation now. And how many folks are familiar with configuring Ether channel? Okay, so we got a few folks here. Okay, so we'll just kind of go over some concepts with it. Just Ether channel in general, we're looking at port trunking between 2 to 8, active fast Ethernet, gigabit Ethernet, or 10 gigabit Ethernet ports. And in comparison to 802.380, just keep in mind, Ether channel is Cisco proprietary, and 802.380 is an open standard. And by default, ESX implements 802.380 static mode link aggregation. So you want to check with your hardware vendors to ensure, if it's not Cisco, just find out what, if they adhere to that standard, but it's static mode. And then we have LACP. So it's one of the implementations included in IEEE 802.380. And that's Link Aggregation Control Protocol. So we're looking at controlling the bundling of several physical ports into a single logical channel. And like I said earlier, that's only supported on the Nexus 1000V. And I have a sample link aggregation configuration here. So we'll see that we have our interface configured for port channel 1, and we'll have the switch ports for each of the ESX hosts configured for channel group 1 with mode on. And we have 2 ports configured similarly the same. So they're in the same basically Ether channel port channel. And we want to make sure that when you set that up, that it's configured properly. So there's a sample configuration. If you're not too sure what to do, you can dive into that and just kind of see. But basically what you're looking for is the port channel to be configured. And once you have that configured, set up the channel group. And it's channel group mode on is what you're looking for, that specific configuration. And then just on the other side, we configure port channel 2. And we have our interfaces configured similarly with the channel group 2 mode on. So keep in mind the supported switch aggregation algorithm is IP source destination, and that's on your physical switch. Some of the older Cisco OSs, they defaulted to MAC-based. And earlier when I was talking about the different options that were available out there, we had the MAC based off of the VM. That's not the same thing, here, and we want to keep those two distinct and separate. What we're looking at is don't change the port the policy to be MAC-based and expect it to work here, because we only work with IP source destination on the physical side. And the other thing is your environment may actually be set on the physical side to do load balancing based off of the MAC-based algorithm. So you can't just change this on the fly. It's a global setting. You could really screw things up, on the physical side. So you want to be very careful before you make any changes, on the physical side. And then on the virtual side, just watch out for, MAC-based doesn't mean the same thing as this algorithm. And really just sync up with the network admin before you make any changes like this, because you'll end up with some really unexpected network behavior. And our actual supported virtual switch NIC teaming mode is IP hash. So that's what matches up with the IP source destination. And then for failover configurations, so we have link status, and that relies solely on the network adapter link state. But we can't really detect configuration errors. So the things that we really want to watch out for, spanning tree blocking comes up quite often when we're vMotioning machines, migrating from one host to another host. You'll see that the virtual machine traffic will get blocked while it's trying to learn what's going on and why that MAC address just moved from one port to another port. The other thing is incorrect VLANs. It could be maybe you set up the right VLAN in the port group, but the physical switch wasn't configured properly. It doesn't have the right VLAN ranges configured on there, or maybe it's not set up for the right switch port access VLAN. And then physical switch cable pools. So we have beacon probing. We can use that and send out and listen for beacon probes. So it's a broadcast frame, ether type here in hex on 5FF. And our best practice for that is to use at least 3 NICs for triangulation. If you only have 2 NICs in the team, we can't really reliably tell which link failed. So we'll go into kind of a shotgun mode with that. So we'll be sending, packets down both links. So you kind of want to avoid that. And best practice, use 3 of them. And then for spanning tree protocol considerations. So with spanning tree, we rely on it to create loop-free layer 2 topologies in the physical network. So our physical links are going to put in the blocking state to construct a loop-free tree. And the physical switches are sending those bridge protocol data units every 2 seconds to construct and maintain that spanning tree topology. And here we can see, we have a block link. For ESX, the vSwitch doesn't participate in spanning tree, so it won't create loops with the uplinks. Our uplinks are expected to always be active. We're not going to block them. And just from earlier, we're taking a look at some of the settings that we wanted to ensure that we had. It was a spanning tree port fast trunk. So our recommendations for the physical network config is leave spanning tree enabled on your physical network and ESX facing ports. And make sure that you use port fast or port fast trunk on the ESX facing ports. And use BDP UGuard to enforce this spanning tree protocol boundary. So I have some tips and tricks for you folks. So let's kind of take a look at those. Is anybody using vSphere 4.1? Okay. Anybody using load-based teaming? Okay, so we have a few. How many are actually using like Ether channel for load balancing? Okay. All right. So if you're not aware of this, so we have load-based teaming. So we can dynamically balance the network load over available uplinks. And that's basically triggered by ingress or egress congestion at a 75% mean utilization over a 30-second period. And you configure that on the DVS via route based on physical NIC load. Now keep in mind the LBT is not available on that standard vSwitch, and it's a DVS feature. We talked earlier about having the ingress and egress traffic shaping, so that's why it's a DVS feature. And then we have network I/O control. How many of you folks use the DRS for CPU and memory right now? Okay. Has anyone expanded that to network and storage? Okay. So that's what basically we're looking at here. So similar things. So we have the DVS software scheduler to isolate and prioritize those special traffic types, contending for the bandwidth on those uplinks. And just similarly to what we do with CPU and memory, but this time for network. And I got together with some of my colleagues in the support center just to kind of go over, what are the top 5 different things that we kind of see that come in. And this one always seems to, for some weird reason, catch some folks off guard. So they migrate, a physical to a virtual machine, but the MAC address was relied on for licensing in an application. And they needed to change the VM MAC address to match up what the physical MAC address was. So just one thing, you can do that, but you don't want to bring that physical MAC address back online in another machine because then we'll have a conflict. But you can do that on the fly while you're trying to figure out how to get that license application relicensed for the new MAC address. And then another one that we see out there, the NLB multicast. So that needs a physical switch manual ARP resolution for the NLB cluster. And that comes up quite often. And there's some tricks that you can do also on some of our other configuration types. But in this one particular, it has to be set up, on the physical switch side. So just keep that in mind there. I see a lot of folks trying to set this up, and they kind of stumble and have some problems. But as soon as they get the KB article and see what configuration actually needs to be done on the physical side, they're good to go. And then we have our Cisco Discovery Protocol, or CDP, which gives us switch port configuration information. So that'll give us the details of the management switch where our ESX ports are plugged into. You'll generally see the native VLAN that's configured, or the management VLAN, and you'll see the IP address of your management switch. How many folks are familiar with the observed IP ranges or the network hints that we provide? I see a lot of folks relying on those to troubleshoot network issues. The only thing is that those network hints that come across is broadcast traffic. So we try to guess, what network is being seen. If you make the mistake and configure, a VM or device on the wrong IP, we're going to pick that up, and you'll be trying to troubleshoot that and chase a red herring, and it's the wrong IP subnet that you're actually looking at. We don't share that config back and forth between the physical switch. It's just we're seeing broadcast traffic for that IP subnet, and we're going to say, okay, well, we see that, that traffic, and we're going to guess at it. So what you really want to do is use Cisco Discovery Protocol to get your switch port configuration, work with your network admin, and actually do that show tech or show run, get the config, and actually take a look at it and see if it's properly configured. I've seen a lot of situations where customers will have, 2 team NICs. One of them's on the correct VLAN config, but the other one isn't. And, it takes us a while to troubleshoot that and try to get a hold of the network admin to get the config over to us so we can take a look at that. So that's a good point. Just start off there to make sure, verify that it's correct, and, you'll save a lot of headache with that. And then quite often what we see here is beacon probing and an IP hash. They don't mix. So earlier we talked about link aggregation, and basically what we're looking at is we expect all of our uplinks to be active when they're configured in this mode here. And with beacon probing, if you try to turn that on, basically what we're talking about, we're going to be taking NICs out of service, and we need 3 for triangulation. So you can't do that if you're in active configuration and taking NICs out, And we basically ignore that. So what you're going to be seeing is duplicate packets and port flapping. You'll see that on the physical switch side. So you really want to avoid that and kind of keep away from that. So once again, just make sure you get the physical switch config and check that. And tip number 5, we talked about it a little bit, but link aggregation is never supported on disparate trunk switches. So with the virtual switch switching or stack switches, we want to make sure that they're configured for a multi-chassis ether channel. I see a lot of times folks try to set those up. They're different, port channels, and the 2 switches aren't really aware of that. Their switches didn't support the multi-chassis ether channel. So it's not the same link aggregated trunk. So you're going to get some really odd and strange behavior from that. Packets aren't going to go where they need to go. And so we have 10 gig E, and we're seeing this a lot, more. So we have 2 CNAs or NICs that we're seeing. It's the most common configuration. And we have a possible deployment method. So we can go active standby in all port groups. Some folks are just limited to having only the 2. So what you can do is you can set the VM sticky to 1 VM NIC, and then the service console or the VMK port group sticky to the other one. Okay. So that way, basically, it just means set your VMs active to let's say VM NIC 0, and service console VMK ports are standby on VM NIC 1. And then you do the opposite with the service console VMK ports. Set those active to VM NIC 1 or 0, and set the VMs sticky or standby to the other one. And we can use ingress traffic shaping to control the traffic type per port group. So we talked about that earlier, setting that policy on the control on the port group itself. And then if you're using fiber channel over Ethernet, use a priority group bandwidth reservation on the CNA utility. So you'll have to go in on that config utility to configure that. And keep in mind best practice, and we kind of see this a lot of times, make sure your drivers and your firmware are up to date. It'll give you the best success. A lot of times these CNAs or NICs, the firmware is out of date. You don't know how long it's been on the shelf. And even with some systems, they may be new models, but you're just not quite too sure, how long how old that firmware is, We get a lot of situations where we start taking a look at that, and there's been several firmware updates. And then, of course, you want to make sure that your driver is up to date as well and compatible. And make sure to check the HCL. For example, vSphere 4.1 supported up to 4 10 gig eNICs. Some systems may come with 6, and there might be a little bit of confusion, with that. So that's one thing you definitely want to do is just make sure to check the HCL, check the driver, and then also check with your vendor and the firmware. So the next section that we have here is troubleshooting virtual networks.
Question on the configuration. Should we separate management and vMotion traffic on a physical layer?
It depends. And partly the reason being it depends. Like if you're doing a lot of physical to virtual migrations, you're going to be utilizing more the management side for that, right? So you want to make sure that that's not contending with your vMotion traffic types or whatnot. Okay. For troubleshooting virtual networks here, let me see. We can start off here with troubleshooting one component at a time. So what we want to look at is the physical NICs, the virtual switch, the virtual NICs, and the physical network. And we have several different tools that are available for troubleshooting. So you can start off with the vSphere client. You can also dive in with the command line utilities of ESX top. You can use the VMA or RESX top as well for ESXi. You can use third-party tools like ping and traceroute, traffic sniffers, and protocol analyzers like Wireshark. How many folks here are actually familiar and comfortable with using Wireshark? Okay, that's good. I like that. So it's really helpful sometimes for us because we have logs that are available, but a lot of times logging doesn't give us much information. We'll find errors in there if there's something specific to a NIC driver, but we don't actually capture any of the network traffic, and that's where these Wireshark captures come in handy, or TCP dumps. So when you're capturing the traffic there, we have the capability of, on our physical switches, to do a mirrored port, span port, and capture traffic there. And what we recommend is that you get a capture off the physical switch when the issue is occurring, and also capture the packet traces within the VM, and capture the packet traces on the vSwitch itself. So what you want to do on the VM side, you can run Wireshark on the VM, and you can also set up a helper VM and put it on the same vSwitch, and so that way you can confirm, is it something specific to the VM that's having the issue, or have that helper VM to kind of capture and see what's going on. And it should either be seeing the same traffic or not seeing it, depending on what your situation is. You'll want to create a port group and set the VLAN ID to 4095, especially if you're doing multiple VLANs, so we can capture all of the VLANs as well. And make sure that you enable promiscuous mode for the port group. So that gives you the ability to actually see all of that traffic and capture it. So the terminology is a little bit different, but as you can see, the networking concepts still apply. It's very similar to the physical side. And then on the ESX server side, or ESXi, what we'll want to do is we'll want to run TCP dump if you're using Classic, or use TCP dump-UW on ESXi. And keep in mind here that right here, we're just looking at one host per se. But if you're having a problem here and basically we want to find out, what's happening to this network traffic, you're going to probably need about, maybe 4 to 6 network captures, and from different points, depending on, where it's going, if it's moving from a data center, or from host to host, and they're plugged into different physical switches. So you'll need at least 2 from each of the physical switches, and then 2 from the ESX host, virtual switches, and another 2 from the virtual machines as well. And we do have a best practice. When you're capturing traffic off of the management interfaces, make sure to create a new management interface specifically for that purpose. You don't want to do anything to harm your existing on networking for the management side. So that's what we recommend. Just create a new management interface and don't change the default gateway. but the management interface will be specifically to be used for the network capturing. So show of hands, how many participated in the vSphere 5 beta? Okay, that's good. Okay. So I just wanted to cover a little bit of what was new in networking in vSphere 5. So some of the new things to watch for, so we can monitor and troubleshoot virtual infrastructure traffic. So we have NetFlow version 5 implemented. We can do the port mirror and span, similar to the physical side now. And then we also support the LLDP, so that's more standard-based link layer discovery protocol. So that will help support and simplify the network config and management in the non-Cisco switch environment. So earlier we talked about CDP, but that was Cisco proprietary. You can only run that for Cisco devices. And then we have enhancements to network I/O control. So we have the ability to create user-defined resource pools and support for a vSphere replication traffic type. So that's a new system traffic type that carries the replication traffic from one host to another. And then we have support for IEEE 802.1p prioritization tagging. So I have a link in here for the What's New in vSphere 5 networking technical white paper, so you can get a little bit more information and some use cases scenarios. So finally, I want to talk about network design considerations. So really what we're looking at, how do you design the virtual network for performance and availability for, and maintain the isolation between those various traffic types that we talked about earlier, like our VM traffic, our vMotion and management. So just, remember, starting point, it depends. How many NICs do you actually have available on the server? And what are those required traffic types? So you'll probably end up with 2 NICs minimum for availability, and we really recommend 4+ NICs per server. I know that's a challenge with some of the blades and whatnot. 802.1q VLAN trunking is highly recommended for the logical scaling. So basically, our VLAN tagging we talked about earlier, and specifically with the low NIC port servers. And then just keep in mind, these examples, they're meant as guidance. They're not, they don't really represent strict requirements in terms of design. But you really want to be, familiar with your network, requirements and needs, and work with your physical network admins. So, and that's just the last point here. So you just understand what those requirements are and design accordingly. So we have an example here of a one blade server with 2 NIC ports. And our candidate design is to have teaming on these for both of those NIC ports. We're going to create one virtual switch. And we'll create 3 port groups. We'll use active standby policy for each port group. How many actually use active standby here at all for any other? Okay, that's good to know. So the first port group here, we're going to have our service console or our management VM kernel. The second one, port group 2, we'll have our vMotion. And then port group 3 will have the VM traffic. And by the way, too, these port groups, if you need to capture traffic, sometimes it's easy to isolate a virtual machine to a port group and then set up your capturing on there so you don't impact the existing traffic that's going across that port group. So it's going to throw it in there since a little relevant. And we'll use VLAN trunking for this configuration. So we'll trunk VLANs 10, 20, and 30 on each uplink. And for the DVS, we'll team over the DV uplinks, which is an abstraction to the actual physical uplinks. In example 2 here, we have a server with 4 NIC ports. So that design, we're taking a look at creating 2 virtual switches. And we're going to team those 2 NICs to each vSwitch. So vSwitch 0 is going to be used as the active standby for each port group. And in port group 1, we'll have our service console or management VM kernel interfaces. And port group 2, we're going to actually put vMotion on that because we know that specifically requires a dedicated traffic type that needs to be isolated. And then on vSwitch 1 here, we'll use originating virtual port ID. And port group 3, the VM traffic, number 1. And it looks like we're going to isolate, based off of maybe some requirement to have our VM traffic, on port group 4 as well for this group number 2. And we'll use VLAN trunking here. So VMNIC 1 and VMNIC 3 are going to be trunked to VLANs 10 and 20, where VMNIC 0 and VMNIC 2 are trunked to VLANs 30 and 40. And we just see there, so VMNIC 1 and VMNIC 3 are for the service console and the VM kernel interfaces, and VMNIC 0 and VMNIC 2 are for the virtual machine traffic types. And once again, we have our teaming over the DB uplinks for the vNetwork distributed virtual switch. And then finally here for example number 3, we have a server with 4 NIC ports. So just a slight variation on this design here. So we're going to be looking at creating 1 virtual switch, and we're going to create 2 NIC teams. So the vSwitch 0 will use active standby for port groups 1 and 2, where we'll have service console on port group 1, and our port group 2 will go on the vMotion. And then for the originating virtual port ID will be used for port groups 3 and 4, and we'll have our VM traffic groups of 1 and 2 on those. And we'll use VLAN trunking. So same thing again here. VMNIC 1 and VMNIC 3 will be trunk VLANs to 10 and 20, where VMNIC 0 and VMNIC 2 are trunk VLANs to 30 and 40. Now, one thing to kind of keep in mind with all of this, you can tell right away there's a whole bunch of different variables and things to throw in the mix. It depends on your needs and whatnot. But you want to be aware of those and watch out for what your requirements are. The one thing I do like about networking is that there's so many different things that you can do, and you think you kind of see everything when you're working in support. But I've seen so many different types of configurations that are out there, and it's not really new to me. I'm really impressed with what you guys can do out there in the field and need to accomplish and whatnot. But like I said, if you can sync up with the network admin and your VM admin and work together, it'll really help with troubleshooting and diagnosing issues for you folks. So everybody should have a worksheet. I just wanted to remind you guys that if you could please fill those out for us, that will be really helpful. And we do these customer support presentations quite often. So if you'd like to get some more information, please stop by the website. And also make sure to stop by the Genius Bar as well, too. My colleagues and I will be there to answer any additional questions that you may have. And we'll get you what you need. So make sure to stop by and visit us. Thank you all for attending, and have a great afternoon.